Well, hello, algebra students and seekers of general truths. In this video and the ones that come afterwards, we will look at some examples of multi-step inequalities. So these are inequalities that involve multiplication, division, addition, some combination of all of them. So let's get right to it. There's nothing particularly new except that there are more steps involved in this. So let's take a look at this first problem. 2x minus 3 is greater than 7, and we want to isolate x, so we're going to add 3 to both sides. And this gives us 2x is greater than 10. And then we can divide both sides by 2, and x then must be greater than 5, all right? And then to graph the inequality, we always start out with this number line, put a 5 on there, and let me change up the colors here a little bit. This is a strict inequality, so we want an open circle, and x is greater than 5, so all the numbers that are larger than 5, in other words, that go towards positive infinity, goes towards the right of 5. All right. Now let's take a look at another one. Let's do number 2 here. 7 times quantity r minus 3 is greater than or equal to negative 13. So here, there's a couple steps. We're going to use the distributive property, multiply 7 by r, so we get 7r, and then multiply 7 by negative 3, so we get negative 21, is greater than or equal to negative 13. Add 21 to both sides. And then 7r is greater than or equal to 21, and negative 13 gives us positive 8. And then we can divide both sides by 7. So we're going to divide both sides by 7. And we get r on the left side is greater than or equal to 8 over 7. Okay. And rather than converting this into some lengthy decimal, I'm going to leave it just as that fraction, and I'm going to graph it on the number line. So 8/7 is somewhere on the number line. And just for a point of reference, it's a positive number. It's a little bit greater than 1. So that's like here 0. And then r is our variable. It's a greater than or equal to, so we go with the filled in circle, and it's greater than, so we're going to go towards the right, just like so. All right, back up here to number 3. And this time we see that there are variables on both sides of the inequality, and that's perfectly fine. We can certainly work with that. So what we're gonna do is try to get all the variables on one side and all the constants on the other side. And you can move 2m to the right, or you can move negative 3m to the left. Either way is fine. I'm going to start out by adding 3m to both sides. And remember, when we add these variables, or an expression with variables, we need to be aware of like terms. So we're not adding the 4 to this. It's just negative 2m and 3m. So the 4 is still there. Negative 2m and 3m gives us positive m. And of course, on the right side, we have 7. These 3m's will cancel each other out. And then to finish it out, we're going to subtract 4 from both sides. So on the left side, I'll write in my extra steps here. Subtract 4, subtract 4. So on the left side, we end up with just m. And on the right side, we end up with 3. So m is greater than 3. And to graph that, draw our number line, put the number 3 in there somewhere, and then it's a strict inequality, so we want an open circle, and it's greater than, the variable is greater than 3, so it's all of the numbers to the right of 3. All right, now we're going to finish this video with the toughest example yet. There are negatives, there are variables on both sides, and there are some fractions involved. And so there are many ways we can do this. I'm going to try to get rid of the fraction before I do anything else. Okay, and if you notice here, it's kind of nice for us because we have division by 3 on both sides. The fractions have the same denominator. So I'm going to put parentheses around the right side, parentheses around the left side. My inequality symbol is going to be exactly the same, so I'm going to write that down here so I don't forget. And then I'm going to multiply both sides by 3. So I'm going to multiply the left side entirely by 3 and the entire right side by 3. Okay? And now let's get to the work of this. So 3 times negative 2/3. So this is, and we can look at this as like 3 over 1. Right? So 3 times negative 2/3, d, is just going to be negative 2d. So the number in the front here and the denominator cancel each other out. And then 3 times negative 2 is going to be negative 6. Over here, we have 3 times 1/3 d. So that's just going to be d. And then 3 times 8 is going to be 24. And so after doing that, we've been able to get rid of the fractions. And now we can simplify this a little bit. So we add 2d to both sides. So whenever I see a negative variable, I prefer to clean up that side rather than moving the other side. So add 2d to both sides. And this gives me, this is gone on the left side, gives me negative 6. And then the inequality symbol. D and 2d is 3d plus 24. All right, now continuing with the problem, we want to next isolate the variable, so we're going to subtract 24 from both sides. And on the left, we get negative 30, the inequality symbol, and then 3d. And finally, divide both sides by 3, and we get negative 10 on the left is less than our variable, d. And I want to clarify something here. We're doing a problem, a division operation that involves negative numbers, but the number that we're dividing by here is a positive number, so we don't flip the inequality. So again, to clarify, we're dividing both sides by 3. Right? We're dividing both sides by positive 3, so we don't want to flip the inequality sign. Even though we have a negative number here. If we were dividing by negative 3, then we would need to flip the inequality sign. All right, so then let's finish this problem by graphing. We have, let's put, negative 10 is like here. And it's a strict inequality, so we're going to go with an open circle. And the variable is greater than the number, so we're going to go towards the right. So there you have it, 4 examples of working with more complicated problems that involve fractions and variables on both sides of the inequality sign.